Welcome, and today we're going to be looking at a new MP3 player. I've seen a few people trying to use these on a couple of the Facebook forums, and I decided to buy a couple just to see how they worked. This board is called a DY-SV5W voice playback module, and it's a little bit different to the sort of DF mini player. If you've used that, I've used those in model railway projects. I've done tutorials on them, but this board is a little bit different, so let's take a look at it. So this board, if you compare it to a mini player, it's quite a bit bigger. And as we look at this board, I'll just explain a few of the parts. The first thing that's different to the DF player is DF player, you've got a, just like this board, you've got a TF card holder, but on the mini player, obviously you've got to load the files onto the card and then put it into the board. One of the nice things about this board is you've got a USB connector, and you can just connect this board straight to your computer with the card already in, and just move tracks straight onto the board. Now that sounds easy. Just one little warning before I start on this one. Just like the DF mini player and some of these other small boards, you cannot select the tracks by the track title or the file name. So your best way of doing this is to name them sort of 0001 0002.mp3. That's how I've named mine, and I find that the easiest way to work through these. I then tend to play through all the tracks. Thankfully, although this thing will take crazy number of tracks, I only tend to have a few on there because they're just railway sounds. But I then play through them and make a note of what track is playing and what number is coming out. Now usually when you put them on, if you put them on the card in numerical order, they will stick in that order. However, there can be some oddities. So let's imagine you've put tracks sort of 0001 to 0009, then you delete track 2 and you put a new track 2 in. Sometimes track 2, even though it's got the same file name, doesn't appear in the second position. You can mess everything up. So I would tend to advise you to get all of the tracks that you're going to put on in a folder and then load them up sort of one at a time, and keep them in the same order for the whole time. So that's file loading. Now other bits on this, different to the DF player, you've got a volume control. Now if you turn this clockwise, it increases the volume, anti-clockwise decreases the volume. That is not the only volume control. There is a built-in way that you can control the volume, and I've tended to leave mine sort of in the halfway position, and it's done the job great. Now one thing that this has that the DF player doesn't have is it's got a 5-watt built-in amplifier. Now that means you can have sort of a little bit bigger a speaker, or it's actually got a 3.5mm audio output, so just a jack plug that you can just plug straight in. After using this against the DF player, this board definitely has superior sound, to the point that all of my projects will be swapping to this from the DF player. So that's the way I'm going with these. I've been very impressed. Now down here you've got some little sort of dip switches, and in the sketches that I will be going through today, we need 1 and 2 set to off, which is this end, and 3 set to on. So that is the mode that we're going to be using, because if you look here, there's a whole load of pins. The pins that we will be using are the VCC, the ground, the TXD, RXD and busy. Now I've made sure on the Digital Town website that I've got the connections I connected in these examples to an Arduino Mega. You could connect this to basically anything, you know, ESP32, ESP8266. If you're using an Uno, you're probably going to have to use software serial, but you know, it'll work just as well. So those are the connections. Now, most of the tutorials that I've seen on this are using these button combinations to control the unit. In my situation, I didn't want that. I wanted as few connections as possible. Hence, originally I was hoping just to get away with these 4. I found later that I actually needed the busy pin as well to make the sketches work the way I want. Now, the way this works, a bit like a DF Mini. Obviously, this is the data sheet. There's a link to it on the Digital Town website. If we go through the data sheet, you know, it can all look a little bit sort of mind-blowing at times, but the important bit for us is this line here. To start with, we want to use UART mode, hence it is connection 3, which is that pin there, set to on, and the other ones both set to off. That's all we need to do. Now, if we go down through the data sheet, we get to UART mode, which is the mode we're going to be using, and there are all sorts of commands here to make the unit do what it wants. There are some oddities compared to the DF player that we'll see in the code. One of the oddities is that when the DF player plays a track, when the track ends, it actually sends information back to your board over serial, whereas this board doesn't. You can query the board, but I found as I queried the board, it affected the way the track was playing, and that's why when we come back to this pin here, this is why I started to use the busy pin, because when a track is playing, the busy pin goes low, so it passes back a value of 0 when you do a sort of digital read off that pin, and when the track is not playing, it goes high. Didn't seem very intuitive to me, but that's the way it works. Anyway, that's the main bits that we need. So there's all these different codes that you can use. Some of these codes look a little bit complicated when you look at them. There are some values that you pass along, and then there are some odd bits here. Now, some of these are different bits of data, and some of it requires, I think it's the SM requires a check bit. Now, in the examples that I'm going to show you, all of that has been sorted out for you, and for the functions that I'm not using, there is a pattern in there on how to use it. So let's get started. Now we're going to look at 3 sketches today. The first one is a very simple one, and the idea with the first one is let's just test the board and make sure that it works. Now, there's no libraries in this. I've written this completely without libraries. The only variables that this first sketch is using are these ones here, and basically we are connecting on the serial pins. Again, let's just remind ourselves, go to the connections on here. So on this first example that we're going to use, we are just using 5 volts ground, RX1 on the Mega to the TX, TX1 on the Mega to the RX on the board. Later on, we will be using pin 8, so if you want to get that connected to the busy pin, go ahead, and again, selectors 1 off, 2 off, 3 on. Right, back to the sketch. So let's go into the setup. I've got the serial monitor running at quite a high baud rate. Serial 1, which is the serial that is communicating with the player board, needs to be set to 9600 because that's the speed that it accepts. And then all I've done is done a quick serial print just to the serial monitor, just that I can check everything's working. Now, when we were looking at the data sheet, obviously there's all these different things that can happen. Do you remember one of the first things I said to you is you can set the things like the volume through a command, and here we have the command there, AA1301. Now, just so those of you who are beginners, these are in hexadecimal. So in the commands, if ever you see 0x, that means it is a hexadecimal value. So if we look at this line, to set a volume to a specific level, we pass AA 1301. So we go AA 1301. Now the volume can be set in steps from 0 to 30. I've set it to 17. I'll be honest, when you've had this thing playing all afternoon, it irritates the life out of you. The volume's quite good, but 17, it's loud enough for me to hear, quiet enough so it doesn't irritate the life out of me. Now, if you remember, I mentioned this SM, which is a checksum. Now, a checksum, if ever you hear someone talk about a checksum, if you're sending a set of data over a communications protocol, one of the problems is, did it all arrive? So a checksum is the way that it makes sure that everything arrives, and what it does is it adds together these values. So that's what is going to be stored in checksum, and we see that here. So I'm going through from q equals 0 to q is smaller than 4, because there are that's 0 to 3. It adds those values together, and then what we do is we put the value into command 4, but we only put the low byte because it's an integer. It has a high byte and a low byte. You don't need to fully understand that at this moment because it doesn't really matter, but it takes the low byte, passes that through, and the board at the other end can do a little bit of mathematics and go, yeah, I'm pretty sure I've got the right amount of stuff come through. The command length is 5 bits of data because in an array we start at 0, so 0 to 4 is 5 items, and then we're going to send the command, and sending the command is a function that I've written here. So it works through the command and it sends the different parts of the command. It writes those bits of data to the serial. Notice that says serial.write, not serial.print. There's a difference, and when you're sending the data you need to use serial write. Serial print, great for the serial monitor for people to read, and the reason I've printed this out is you can go to the serial monitor, see this thing run, and you'll see the commands coming through. Now, so that's the first command set. We've set the volume. If you didn't set the volume, I think the default is about 20. It's annoyingly loud, but yeah, so you can miss that out if you want. Now what we're going to do is we're going to select a random, put the board into random play mode. Now this is set loop mode. Bit of a strange way of writing it, but if I scroll up to here, there are various different modes, and the mode we're going to use is random play, which is 3. So we've got that command going back. Where are we? Set loop mode. So our values are AA 18, 01 and 03 is the mode we're selecting. We're then doing the checksum just as we've done before, and we're sending the command. So that's now put it into random play mode. The strange thing is, of course, at this point it doesn't play. So it's saying, right, I'm in that mode. We then need to send it the command to play a track. And that command, if we look there, AA0200AC, those are the command bits. There's no check bit on this. So command length of 4, and it sends that data across. And if you run that sketch, whatever MP3 files you have put on your SD card will play in a random order, and you know the unit's working. So that's the end of sketch number 1. So here's our next sketch, and the difference with this one is we're going to use the busy pin, and that's going to be pin 8, so it's set here. Most of the rest of it is similar. There are a few other bits that I've used. I've got a few variables: track number, play status, last check time, current millis, and busy pin state. You'll see why as we go along. One of the other things that I have done as we go through this, I've taken some of these different commands and I've turned them into functions just to make life easier. So instead of having to keep typing this out every time, if I want to play something, I can just select play. So let's have a look at it again. Usual serial setup, serial to the serial monitor, serial 1 that is going to be writing to the MP3 player. The busy pin, we're setting it as an input because it's going to be receiving data from the busy pin on the board. And this is the first of the functions that I've called. If you remember on the previous one, we saw a set of commands. Now all we're doing is we're going to go playback volume 17. And if I scroll up here, you will see the let's just stretch that down a bit so we can see a bit more. There is the function from there to there. So it receives a value for the volume. What I then do is I just check that that value isn't higher than 30 because the maximum volume is 30. So that's just a little check within the function. And then it's sending, just as in the first sketch, the various values through with the volume, does its checksum, sends the command, does everything. But instead of it having to be written out every time I change the volume now, I can just call this function. Now in this loop, what I wanted to do was just play the tracks on my SD card and then have a gap. So all the code that I try to write I want as non-blocking code, and that's important because if you want to have other effects running, you don't want tons of delays in your code because that's going to mess everything else up. So we're going to use state machine style code, and for that we need to use the function millis. Now in my sketches I tend to have a value at the beginning of the loop called current millis because I use that throughout the sketch in different places. Then we've got the busy pin state, and the busy pin state is reading the busy pin. Now if no track is playing, we're going to get a value of 1. If a track is playing, we get a value of 0. So if we have an if statement over that, if the busy pin is greater than 0, 1, nothing's playing. If the play status is smaller than 1, we're going to set the play status to 1. Now the reason for doing this is if we didn't have this line in the fractions of a second it takes to get to the next part of the sketch, this thing is going to run over and over and over. So once it's set a play status, the play status is now 1, and it also sets a value for the last time. It's setting the last check time making that equal to the current millis. You'll see where that goes next. So then I've got a switch statement. So if the play status is 1, so nothing's playing, and what I'm saying is if nothing's playing, I want to play a track, and I want to do that every 2 seconds. So we've set this value up. The system is looping round and round. It's going, yep, play status is 1, and it's waiting until the last check time is 2. There's a difference of 2000 between the current time, current millis, and the last time the system was checked. 2000 is 2 seconds. When it does that, it sets the play status to 2, and it selects the next track to play. Now, I've only got 5 tracks on the board, so I play a track. Again, I've written a function this time, play a track with a track number, and what that does is it goes up here to play track, and it receives the value of the track that I'm playing. That is not the file name as such, although it might be equivalent to the file name depending how you've loaded them on the SD card. But what it is doing is calling, where is it? This one here, specified song. So I'm specifying which song I want the unit to play. Those values are passed over. Again, you don't need to worry about that because it's all written in there. The high byte and the low byte are those values, SNH and SNL. The reason is you're sending the data over in bytes. An integer is 2 bytes, so we split it into a high byte and a low byte, send up across. We've got the same old checksum stuff. This time we've got a command length of 6, and off it goes. Command is sent across. Okay, once we've sent that across, oh, and by the way, when it says play specified song, you then don't have to select play because it's going to play it. Now, once it started playing, I then change the track number for the next track. Now, I just incremented it by 1. If I'd left it like that line here, track number, it would keep playing track number 5, or I could get it to play my own version of random by playing a random track between numbers 1 and 5. Anyway, our track is now playing. Our play status is 2, and when the play status is 2, all the system is doing is just checking the busy pin. Once the busy pin drops to, if the busy pin is below 1, then the track is starting to play. We're going to put the play status back to 0, and what that's then going to do is start the whole system again. So every 2 seconds there'll be a gap of 2 seconds, then it's going to play a track. 2 seconds, it's going to play a track. Give it a test and you'll see how it works. Now for this final sketch, from a model railway point of view, yes, I want some background sounds to be playing, but sometimes I want those sounds to interact with something that's going on. So it could be interacting with maybe a railway crossing that's lifting. When the crossing's lifting, I want the bell sound to play, and at the same time I want flashing LEDs. The example I'm going to use today is an arc welder. So what my sketch is doing, it's got 5 sounds on the board, one of which is an arc welder. When the arc welder plays, the arc welder sound plays, I want the LED to flash. So let's show you this in action. Now you can be thankful that I didn't go through all 5 sounds, but as you can see, when the arc welder sound is playing, then you get that white flashing LED. So let's go through the code. The big difference, we've got pin 9, which is the arc welder pin, and I have put in the sketch. Again, all these sketches, they're all on the Digital Town site, so you can download them however you want. These are the variables that are required for the randomness of the arc welder. Now you'll see below we've got some of the functions that I've written. One of the things about these functions is if you go back to that sheet, if you've got a different item that you want to use, you can just use the same basis. Just take this apart. You can see how the checksum's working, so you can use that sort of thing as well. Right, let's get to the sketch. So the big difference when we started up, we've got a busy pin as an input. Now we've got the arc welder as an output. So the arc welder is just a pin. I'm using pin 9. It's connected to the LED with a 330 ohm resistor. Then we're going to go into the loop. Now the loop now starts to get a little bit more complicated. So once again, we start with our current millis. We've got the busy pin, and then we've got all the status that we saw in the previous sketch. So as I've written these sketches, I'm sort of building up towards this goal. So again, everything you've seen in the previous sketch is in here. The only difference is realistically right down here we've got the arc welder function. It's basically calling this function arc welder. So as we've seen before, it's playing the tracks through at for mine it's incrementing them. Again, it could have been random, there could have been 100 tracks on here, but on my particular system, when it gets to the 1 track, and we're going to go up to the arc welder function, if it goes to a very specific track, then the arc welder starts. So going back to the main loop, one of the bits that I changed is with the play status. If the play status is smaller than 1, nothing's playing, so I want the arc state set to 0. I don't want anything happening. Now when we then get to play status, when we have this function here where we play the track, so it sends the track number through to the function play track. Just before that, I've got this little if statement. If the track number is equal to number 5, notice 2 equal signs. That does not mean if you put track number equals 5, the variable track number becomes the value of 5. What we're doing here is we're checking, is the current track number 5? If it is, it puts the arc welder state to 1. When that value goes to 1, when the loop goes round, the arc welder function plays. So at this point, let's imagine we played the sound, track 4, it's a horn, nothing's going to happen. Track 5 gets played, this goes to a value of 1. At this point, every time we get to the bottom of the main loop, it's calling the arc welder function, and the first thing it's saying is, what is the value of arc state? So if it's greater than 0, great, let's start doing some work. If it's not greater than 0, it turns the LED off. Now this is important because one of the issues that you can have is when you're doing something that's using random, who knows at what point random is going to end. So it could end the random welding while the LED is lit. So the way this sketch works is if the LED, if the arc welder is turned off, it checks on every cycle that the LED is turned off and it turns it off. So what we're using here, I've got an arc timer and an arc timer period, and we've got two states for the LED. One is 0, one is 1. So if the LED is turned off, turn it on. And again, the alternative to that is if it's turned on, turn it off. It's that's the way it works. Now, to make that flicker go in a very random format, as someone who's actually done some arc welding over the years, the way that the flicker tends to work if you're welding is that there will be more, if you like, light on than light off. So it's flickering on and off very quickly, but on the whole it always appears like the bright light is there for more than the off time. So what I'm doing is setting a random value between 40 and 100 for the on time and some slightly smaller values for the off time. Now again, these are random, so it's all getting mixed up, and these are setting the period that goes in here. Now when we're looking at these values, these are in milliseconds. So 100 milliseconds is 0.1 of a second. This is 0.04, 0.02 of a second. So we're talking very, very fast changes of state, but that's what gives the LED that nice sort of flickering look. And so that's basically what's happening. Every time track 5 is called, it's sorry, gone down, not gone down far enough. Every time track 5 is about to be played, it starts the arc welder, the sound starts, and when the busy pin goes high and therefore the track has finished playing, at that point the arc state goes to 0. Now the reason I've done it this way is I didn't want to get to a situation where I had to work out the length of all of the tracks. If I get a new arc welder track, and in fact I've got two arc welder tracks that I can use, what it allows me to do is if I've got two arc welder tracks, I could then go, if track number is 5 or track number is 10, then go through the arc welder thing. You could then have another if statement. If track number is 2, which might be your crossing, then start flashing lights at the same time. All of these things can be integrated, but I just wanted to show you this example just as the way that Arduinos can be made to interact both audio and visual at the same time. So I'm happy with the initial effects I've got off this. I'm very happy with the sound quality. My microphone probably doesn't pick it up particularly well, and I'm using a really dodgy speaker for my setup on the desk, but I am impressed with the sound. When I've put it onto some better speakers, it has been very, very impressive. And as I've said, any projects that I've got that are built into the baseboards where I've got plenty of space to put these boards, because these boards are a little bit bigger. They're about 50mm by 50mm, something like that. It's not huge, but it's bigger than a DF player. They seem to be great boards. They're pretty cheap in the UK. They're about £6 by the time you include the postage. You can probably get them a bit cheaper off somewhere like AliExpress if you're willing to wait a couple of weeks. But a good board, and I think very, very useful certainly in the model railway world. So hope that's been useful, and if it has, please click the like and subscribe. Bye for now.